Hello children, we'll continue refraction part A. Turn to page number 72. Before speed of light in this, there's one portion called effect on speed, frequency and wavelength. I hope you're able to see. I'm going to do this topic, effect on speed, frequency and wavelength due to refraction of light. Now, so what are the things that will change and what are the things that will not change? Okay. Now, if you remember in the explanation, I told you that frequency will never change. Okay. Whether it is traveling in air or in water or in glass, its frequency should never change, will never change, and therefore time period will also never change. But speed and wavelength will change. Okay, so I'm going to make a table like this, and I would suggest there is no space here, so I have made this table in page 77. Okay, in page 77 there is a slight space here, so I have made the table here. It is easy to remember. Okay, so this is denser to rarer and this is rarer to denser. Okay, so we are going to see about three things. Okay, so speed or velocity. Okay, so I am taking it as V, frequency F and wavelength lambda. Wavelength lambda. I hope you remember this relationship that we studied in last year also. That is, what is the relationship between speed, frequency and wavelength? V is equal to F lambda. We had it for sound also. Okay, this can be true for light also. Velocity of light is equal to frequency of light into wavelength. Okay, now coming to this one. So, whether the light travels from denser to rarer or rarer to denser, frequency you can write no change. Frequency should not change or will not change. Is it clear? Now, when it travels from denser to rarer, will the speed increase or decrease? Speed will increase. Denser medium to rarer medium, so speed will increase. Rarer to denser, speed will decrease. Okay, speed will decrease. Now we have to see about lambda. Now from this, we get lambda is equal to V by F. F is constant, so lambda is directly proportional to V. So, however V affects, means however speed is affected, the same way wavelength will also be affected because they are directly proportional. That means denser to rarer it will increase and rarer to denser it will decrease. So you can note this down children, it will be easy to study from this. So what are the things that changes, what will not change? Okay, frequency no change, no change. Denser to rarer, speed increases, wavelength also increases. Rarer to denser, speed decreases, wavelength also decreases. So it will be good if you could note it down as a table, then it is easy for you to recollect. Okay, next we go to the next topic. Come to page 73. Conditions for a light ray to pass undeviated on refraction. Conditions for a light ray to pass undeviated on refraction. So in page 73, if you can see towards the end, there are two conditions given. When the angle of incidence at the boundary of two medium is 0. So yesterday itself case 3, if you remember, we saw whenever a ray of light is incident normally there will not be any refraction. Okay, the ray will go like this. Or I can say, if angle of incidence is 0, angle of refraction is also 0. That is the first condition. Okay, when the angle of incidence at the boundary is 0, then angle of refraction is also 0. That is the first condition. Second condition, when the refractive index, okay, when the refractive index of medium 2 is the same as that of medium 1. Okay, when the refractive index of medium 2 is the same as medium 1. What is it? What do you mean by that? Now, suppose light is traveling from, suppose you take it as rarer and denser, but both their refractive indexes are same. This is also refractive index, having a refractive index 1.5. This is also 1.5. Now, basically, this means they both are same medium. Okay, then also the light will go undeviated. Is it clear, children? So this comes sometimes as a 2-mark question. Put a tick mark here. What are the 2 conditions for light ray to pass undeviated on refraction? Now, turn straight away to page number 76. Okay. Now, in between, yeah, children, in page number 74, you can strike off this relationship between wavelength in the 2 media. This part, and all can be struck off. Okay, it is not there in the syllabus till this. Okay, now here I have written study only conclusion. Study only conclusion. Now, what you have to study here is, if suppose refractive index of, now suppose light is traveling from air into glass, okay, and so you found the refractive index of glass with respect to air. Now here I want to tell you one more thing. So it will be bending towards the normal. Okay, now when I write the refractive index, on the right side I will write the medium into which it is going, or simply if I take, this is medium 1, this is medium 2, on the right side I'll write the medium into which it is going, on the left side I'll write the number from where it is coming. Is it clear, children? So it will be mu 2 1, refractive index of second medium with respect to the first medium. So if it is glass, if light is coming from air entering into glass, what I get will be refractive index of glass with respect to air. Refractive index of glass on the right side, the medium into which it is going, on the left side, the medium from where it is coming. Okay, now suppose this is 1.5. 1.5 is 3 by 2. Okay, we know that refractive index of glass is 1.5, so I am just writing the answer directly. Now then, or I can say refractive index of glass with respect to air is 3 by 2. There is one principle called principle of reversibility. Principle of reversibility. According to this principle, refractive index of glass with respect to air will be 1 upon refractive index of air with respect to glass. They both are inverse. 1 upon the other one. So by that way, if refractive index of glass with respect to air is 3 by 2, then I can conclude refractive index of air with respect to glass will be 2 by 3. Will be 2 by 3. Okay, the thing is, if suppose the light is going from here, okay, now the incident light is coming from here and it is entering into a rarer medium, it bends away from the normal, and in this case if you find the refractive index of air with respect to glass, that will be 1 upon refractive index of glass with respect to air. So this, the derivation of it is given, so you don't have to know the derivation. If it's enough if you write the conclusions alone. So I've written study only conclusion. If refractive index of glass with respect to air is 3/2, then the refractive index of air with respect to glass, mu Ag, will be 2/3. In the next topic, experimental verification of laws of refraction. This will be doing it practically. So I want you to write it practicals and leave it. We'll be doing it in the lab when you come to school. So that experiment goes till this. That experiment goes still this. Okay. Now the next topic we have to start is refraction of light through a rectangular glass block. Rectangular glass block. Now, so this is a rectangular glass block. Okay, so it's a three-dimensional one. So it's a thick one. It has a thickness. So this is what is the rectangular glass block they're talking about, and the ray diagram. So in practicals, what you will actually do is you'll be performing the experiment keeping this glass block. I don't know whether you're able to see. You can see the letters lifted up. When you see through a glass block, you see from the side, actually it looks as if the Selena publishes, that looks lifted up. Okay, that's due to refraction. That we'll see in the in the C part about applications of refraction. Now I'm just showing you. Okay, so this is a rectangular glass block. Now we are going to see how the ray diagram will look like when light passes through a rectangular glass block. So we are going to see about refraction through a rectangular glass block. Okay, basically it's a ray diagram. So we are going to show the rectangular glass block like this by a simple rectangle, and I want you can write here as air, here as glass, and here as air. Okay, from air it enters into glass, from glass again it comes out into air. Now suppose this is the incident ray. You can take it as PQ. PQ is the incident ray. Immediately at this point you draw a normal. Draw a short normal, not a long one. Okay, the PQ here. Okay, now how will the path go? Light is travelling from rarer to denser, so it will bend towards the normal. So this was the original path. It should have gone like this, but it won't go like this. It will bend and go like this. This is the refracted ray. Okay, so QR. Now you can keep labeling it PQ, QR. Okay, we'll come to that later. So then, now here again at this surface, it's entering from a denser medium, it's coming into a rarer medium. Just the opposite of what happened here. Here it was rarer to denser, but at this surface it is denser to rarer. And you know that when the light ray travels from denser to rarer, it will bend away from the normal. So it will bend away from the normal, it will go like this. Okay, so first let us name it. PQ is the incident ray. PQ is the incident ray. QR is the refracted ray, and RS is the emergent ray. Okay, RS is the emergent ray. It will be good if you can pause your video and keep drawing along with me, children. Then you will understand it better. Okay. Now what happens here? The ray that should have gone like this if this glass block was not there, this ray would have gone like this. Yes, it would have just gone straight like this. But because of the presence of this glass block, bending happened here and here, because of which the ray is now going like this. Okay, so the ray that should have gone like this will be going like this, and if you observe carefully, these two lines will be parallel. Okay, the original path will be parallel to the emergent ray, and does parallel rays ever meet? No, they never meet. So what can I conclude is, because of the presence of the glass slab, the ray just got displaced by some distance, but there is no angular deviation between them. Okay, the ray that would have gone like this is slightly displaced from here to here, and this displacement has a special name called lateral displacement. Okay, now before coming to that, we'll mark the angles children. This is angle I, this is angle R, this also is angle R, both will be same. Okay, angle of refraction R1, R2 we can say, and then this is angle E. Angle I is angle of incidence, angle of refraction R1 and R2 are angle of refraction, angle E is angle of emergence. Okay, then the next thing is lateral displacement. Now what you have to do is, if you measure the perpendicular distance between these two, okay, perpendicular distance between these two, that is given a name called lateral displacement. Lateral displacement. So the definition of lateral displacement is, it is the perpendicular distance by which the original ray has deviated from its original path. The perpendicular distance by which the original ray has displaced from its path and it's going in another path. That is called lateral displacement. So when you perform this experiment also, you will be asked to calculate the lateral displacement. A particular slab will have a particular lateral displacement. So one thing you have to remember is, in a glass slab, no angular deviation is there. Okay, there is no angular deviation, but there is only lateral displacement. Okay, this has a significance when I do the next thing, that is prism, so that then you will understand it better. I hope you understood this diagram clearly. So draw it properly. Make sure this emergent ray comes parallel to this extended incident ray. These two should be parallel, otherwise your diagram is wrong. Okay, draw it in such a way that this is parallel to this, and please use scale and pencil, and make sure you are marking all this PQRS and all that. Okay, so this is a important diagram that comes in the exam. Now let's open the book and see what we have to study from the book. Yeah, please turn to page number 76. Okay, this is the topic we saw, refraction of light through a rectangular glass block. As I told you, the diagram is very important. You can put an important mark here, and you can go through the explanation, and here comes the definition of lateral displacement. So you can write, define lateral displacement, and the answer will be the perpendicular distance between the path of emergent ray and the direction of incident ray is called lateral displacement. The perpendicular distance between the path of emergent ray and the path of incident ray is called as lateral displacement. I have put a block on the word perpendicular distance because it's important to write perpendicular. Don't just write distance, marks will be cut. Please write it as perpendicular distance. Now coming to factors affecting lateral displacement. So lateral displacement depends on three factors: thickness of block, angle of incidence, and refractive index of block, that will depend on the wavelength. Okay, so you have to memorize it like this. And remember, with thickness it's directly proportional, in the sense thicker the slab, more will be the lateral displacement. Angle of incidence also directly proportional. More the angle of incidence, more the lateral displacement. More the refractive index, more the lateral displacement. So you remember these terms and then remember how they affect also. Direct and direct. Okay. So here is where I have written that table, and over here I just wrote see table in page 77. See table in page 77. This way, children, it will be easy for you to study and you can remember it better. That is the major thing. Okay. Now we go to the, so as I told you, this part is not there. Multiple images. Okay, I cut it from the syllabus also. Okay. Now we go to the B part. B part, that is refraction of light through a prism. Now so far we saw about glass slab. Now we are going to see about prism. Okay, are you able to see? So this is a prism. Okay, so if you watch carefully, it has 3 rectangular faces. One here and one here. 3 rectangular faces and 2 triangular faces. Okay, a prism has 3 rectangular faces and 2 triangular faces. Okay, so it's a again a 3-dimensional object. So these 3 rectangular surfaces are called the refracting surfaces. Refraction will happen from them only. Okay, and then this angle is called angle of prism. This angle is called angle of prism. Okay, so this is little bit idea about prism. Now all that we are saying, I told you this chapter is refraction through plane surface. See, these are all plane surface. The next chapter will be curved. Okay, this is also a plane surface, straight surfaces. There is no curved surface. Okay, now we are going to do the ray diagram of refraction of light through a glass prism. So please pay attention and draw it along with me as I teach it. So the next topic that we are going to see is refraction through a rectangular prism. Refraction through a rectangular prism. So, sorry, triangular prism. It's not rectangular prism. It's triangular prism. Rectangular glass slab and triangular prism. Now, you have to draw a triangle. You have to draw a triangle like this. Okay, as I told you, this is the angle of prism. This is called the base of the prism. Now let us take PQ as the incident ray that is coming from here, and you know that this is air, this is glass, again this is air. Okay, so the ray will go into it and then come out through this medium, this surface. So PQ is the incident ray that is incident on this surface of this refracting side of the prism. Now what you will do, so you have to draw a normal here. Okay, normal, children, roughly it should make 90 degree. Most of the time, you know, you all draw like this. This is not a normal. Please pay attention when you draw. This is the normal. Okay, now the ray should have gone like, the ray should have gone like this, but when it travels from rarer to denser, it will bend towards the normal, and therefore the ray will go like this. The ray will go like this. And again, at this point, you draw another normal, and the ray should have gone like this. Now it is denser to rarer, so the ray should have gone like this, but it will go like this. So PQ is incident ray. Okay, QR is, so I want you to write it separately. Okay, PQ incident ray, QR refracted ray, RS emergent ray. This is like the labeling. You can please do write it, children. PQ, QR and RS. Okay. Now this is how the diagram of refraction through a triangular prism look like? Now let's analyze it a little bit. If you remember, in rectangular glass block, the emergent ray and the incident ray, they were going parallel. So the conclusion was there is no angular deviation because of rectangular glass block. Now if you see this diagram carefully, now without this prism, the ray should have gone like this. Yes, without this prism, the ray should have gone like straight like this. But because of the prism, it bent twice, once here, and it is going like this. And it is going like this. Now there is, if you see them carefully, there is an angle deviation between them. So to find that, what should I do is, I should extend this emergent ray back. Okay, you put a dotted line and it's like an extension from the emergent ray, and mark this angle. This angle is the angle of deviation. The ray that should have gone like this is now bent and it is going like this, making an angular deviation between both the rays. Okay, so this is the main difference between refraction through a glass block and through a prism. Now the major, why is it happening is because both the refracting surfaces are inclined by an angle. Now in a glass block, the refracting surfaces, these are the two refracting surfaces, they are parallel to each other. That's why the emergent ray also went parallel to the incident ray. But here, the two refracting surfaces are inclined at an angle. Therefore, it is also undergoing an angle of deviation. So here, del is called angle of deviation. So what is angle of deviation? The angle by which the emergent ray gets deviated from the original incident ray. That is called the angle of deviation. Is it clear, children? So this is how the diagram looks, and please mark the angles. This will be angle of incidence. Okay, this will be angle of refraction. You can take R1, this is R2, and this is angle of emergence. And please write it. Angle I is angle of incidence, angle R is angle of refraction, and angle E is angle of emergence, angle A is angle of prism. Okay, and del is the angle of deviation. There are 5 angles that are there. And so make sure you draw this diagram neatly in your notebook using scale and pencil. Is it clear, children? Yeah, turn to page 83, children. Deviation by a prism or refraction through a triangular glass prism. Okay, now this is the diagram that I drew. Now I have written here study from notebook. Okay, this diagram looks a little complicated because the deviations that he has shown, the angles that he has marked are quite confusing. Okay, so according to this, he has taken this as I1 and I2. That can be confusing. You just take this as I and this as E, angle of incidence and angle of emergence, and angle of refraction, say R1 and R2. This is angle of deviation. You need not show these two angles and all that. That's a major thing. Okay, now coming to the right side, so you can go through the theory. So in each refraction, the ray bends towards the base of the prism. Now coming to the first thing, define angle of deviation. Define angle of deviation. So the answer will come like this: the angle between the direction of incident ray and the emergent ray is called angle of deviation. Angle between direction of incident ray, okay, you can cut off this part, and the emergent ray is called angle of deviation. That is the definition. Okay, now, so as I told you, there are many angles in this, right? Angle A, angle I, angle R1, R2, there are 2, and then angle E also, and angle del also. There are 5 angles in this, the diagram. Now, there is a relationship that can be derived from between all these angles. Now this is the derivation, but in your syllabus you don't have the derivation. It will be enough if you know the conclusion. He has given the conclusion here. Again, it is based on the diagram that he has made. Now, based on the diagram that we have made, so the conclusion will be like this. Angle I plus angle E is equal to angle A plus angle del. Okay, angle of incidence plus angle of emergence is equal to angle of incidence plus angle of deviation. Okay, you just memorize this, children. How this came, you don't need to know now. You have it in 11th or 12th. Okay, so I have written here relationship between angle I, E, A and del. Angle I plus angle E is equal to angle A plus angle del. So if it is enough if you know this by heart, you don't need to know the derivation. Okay. Now come to the next thing. There are lots of information in this one passage, so that's why I put number 1, 2, 3 so that we don't miss anything. Okay. Come to this one. That is, this note talks about how does refractive index produced by prism differ from that of glass block. So I've been telling you, in a glass block, the emergent ray will go parallel to the so the emergent ray will go parallel to the incident ray. So there is no angle deviation. It is only shifted perpendicularly by some distance. Whereas in a prism, there is an angle deviation. So in a prism, the refraction occurs at two inclined faces. Okay, because of the structure, and these two refracting surfaces are inclined at an angle. So the emergent ray is not parallel to the incident ray, but it is deviated towards the base of the prism. But on the other hand, in a parallel sided glass slab, so in a glass slab the two surfaces are parallel, so the refraction occurs at two parallel faces. So the emergent ray is parallel to the incident ray with a lateral displacement. So this comes as a 2-mark question. How is the refractive index produced by a prism different from that of a glass slab? Now, next we go to the next thing, factors affecting angle of deviation. Okay, in rectangular glass slab, lateral displacement was an important topic. Here, angle of deviation is the important thing that we will be focusing on. Now, 4 factors. Okay, angle of deviation depends on 4 factors. Angle of incidence, material of prism, angle of prism and color or wavelength of light. Okay, and this is I've written direct and inverse. I'll explain you shortly why. And this is directly and inversely. Okay, so you should know the name of the factor and how they affect also. So this chapter has a lot of things to memorize, children. So please, you have to do it. There's no other choice. Yeah. Now, this is very important. How does angle of deviation depend on angle of incidence? This is a very important thing. Out of all the factors, this is very important, and this keeps coming in the exam very often. And I have written direct and inverse, which looks really funny, right? Either you will have directly proportional or inversely proportional. But this particular thing is directly also proportional and indirectly. Okay, how are we going to explain it? So, what happens is, this is a graph between angle of incidence and angle of deviation. We are going to see the variation of angle of deviation with respect to angle of incidence. Now, what will happen is, up to a certain angle, when the angle of incidence increases, angle of deviation will decrease. So your graph will go like this. It's an inverse graph. Beyond a point, then it will reach a minimum point. That point is called angle of minimum deviation. We'll come to that later. Beyond this point, when angle of incidence increases, angle of deviation also starts increasing. Can you understand? So this graph, first part is inversely proportional and this part is directly proportional. For some part it will be inversely proportional. For the rest of the part it will be directly proportional. And then here this one you mark it as del minimum. This is given a special name called angle of minimum deviation. Okay, this is the angle where the deviation will be minimum, and that's called angle of minimum deviation. Okay, so this graph is very important. I tell children to remember it as U. Okay, shape of U. Now, so this paragraph talks about the explanation of I-del curve. So how does angle of deviation depend on angle of incidence? Explain it. If they ask the explanation, you will write this. As the angle of incidence increases, angle of deviation first decreases, reaches to a minimum value for a certain angle of incidence, and then on further increasing the angle of incidence, the angle of deviation begins to increase. Okay, and then comes the diagram. I put that as number 5. Okay, the fifth thing you should study here is the diagram, I-del curve. Okay, then there's one thing called minimum deviation position. Now, whenever minimum deviation is happening, two conclusions will be there. Two conclusions in minimum deviation position. Conclusion number 1 is here, angle of incidence is equal to angle of emergence. Conclusion number 2 is here, in the position of minimum deviation, the refracted ray inside the equilateral prism, inside the prism is parallel to the base. Okay, I just want you to remember like this, conclusions in minimum deviation position, angle of incidence. Okay, so this is a special position, angle of minimum deviation, which this angle and this angle will be equal, and this ray will be parallel to the base. Otherwise, this ray will not always be parallel to the base. It can go like this also, but only in one case it will be parallel to the base. That is called the minimum deviation position. Okay, children. So now what is position of minimum deviation? Define minimum deviation. So you can mark here number 8. The position of a prism with respect to the incident ray at which the incident ray suffers minimum deviation is called position of minimum deviation. The position of the prism for which the incident ray will suffer minimum deviation is called position of minimum deviation. Okay, so then you can strike off this. This is also to be done practically, and then here they're talking about the other 3 factors, and as I told you, they are not so important. It is enough if you know that this is directly proportional, this is also directly proportional, and this is inversely proportional. It's the first factor that is very, very important, and there are so many questions that is possible in this one graph. It's based on this graph itself. I hope things are clear for you, children. So read through it and make sure you do both the diagrams along with me as I teach. Thank you so much.